Hello and welcome to this lesson on DevOps Overview. I'm Mahendra Mehra and I'm a senior training lead and evangelist with Parkal University. So let's get started. Let's try to understand DevOps through a story. Head and Heart Holistic Healthcare is a mid-sized business that develops healthcare and wellness software applications. During the COVID pandemic, their business skyrocketed and they are being challenged to scale their development and operations very rapidly. The company started with the waterfall model of development 10 years ago, and since last 5 years, they've been using the agile model. However, they are struggling to keep up with the customer demand and the competitive marketplace. Let's meet our key players and listen to some of the specific challenges that everyone is facing. Meet Jamal from the development team and Trisha from the operations team. The relationship between developers and IT operations is often adversarial. Typical challenges for developers such as Jamal include being pressured for on-time delivery, grappling with issue resolution, implementing new application capabilities, ongoing need for code management, and long and slow software release cycles. Typical challenges for operational leads such as Trisha include resource contention, analysis and diagnostic checks, fast issue resolution, constant demand for redesign, and keeping up with the customer request to edit or tweak. When a client has complaints about a software, the blame is internally thrown at each other. The developer team would point fingers at the IT ops team, and then who would redirect the same blame to the dev team. For example, Jamal would say the code worked perfectly on his machine, where Tisha can argue that the code submitted by Jamal wasn't proper and it broke in the production environment. So overall, what developer wants is frequent changes to be pushed to production environment, whereas the operations want prod environment to be stable. But what business needs is both, that is quick changes and stability at the same time. Meet Ramona, the CEO of Head and Heart Holistic Healthcare. She has heard from both her development and operational leads, and she knows they are struggling and working in their own silos, which is negatively impacting the company. She then makes a call to an Oracle architect, Mo, and shares some of her specific concerns. She tells Mo about how her team can't seem to coordinate their production activities and tasks. She then goes on to explain about the customer losses and complaints, as well as the mounting opportunity cost and the strategic impacts on the business and the financial plans. She asks for help. Mo, the Oracle architect, listens patiently and then offers a resounding yes in order to help her overcome these challenges. Ramona and Mo spend an hour on the phone, and Ramona outlines her issues like deployment delays, high operational cost, communication issues, problems with security, high failure rate, erratic code execution, and no plan to implement continuous integration. Mo takes notes, but knows all along that he has a perfect solution and asks Ramona if she has heard about DevOps service, and then goes on to explain her regarding the OCI DevOps services. Now that we know the challenges a software development team faces who uses a traditional software development approach, let's try to understand what DevOps is and how it helps overcome these challenges. Let's begin with DevOps definition. DevOps is a way of working that allows for continuous delivery. DevOps encourages collaboration between teams such as development and operations who are working in silos. DevOps enables automation, basically using automation tools that can leverage an increasingly programmable and dynamic infrastructure, which helps in increasing the pace of releases, improve your product faster, and build competitive advantage. DevOps instills a continuous culture where it represents a change in IT culture focusing on rapid IT service delivery through the adoption of agile, lean practices in the context of system-oriented approach. For DevOps to be effective, all what is required is a paradigm shift. Enterprises must make this paradigm shift to digital transformation. So we have defined what DevOps is. Now let's discuss why it matters. DevOps brings development and operations team together to create a unified infrastructure. And this team collaboration maximizes productivity, simplifies the software production lifecycle, makes each phase programmable and dynamic, helps you improve release and deployment frequency, along with maximizing predictability, efficiency, and security. It aids in release management and helps you find bugs early in the software development lifecycle. Let's look at the DevOps lifecycle. It is defined as a rapid release, multi-phased software development lifecycle. And in addition to having a built-in strong feedback loop, this lifecycle is stress-driven to ensure robust software and uses code that is continuously built, tested, released, and monitored. Now let's have a look at the lifecycle phases. On the dev side, you have plan, code, build, test, and the operation side, you have release, deploy, operate, and monitor. So we have defined the DevOps software development lifecycle and its 8 phases. Let's take another view and look at these phases laterally. So the phases are plan, code, build, test, release, deploy, operate, and monitor. The agile development covers phases like plan, code, and build, where it organizes work in short iteration called sprints to increase the number of releases. Agile emphasizes on software development methodology for developing the software. When the software is developed and released, the agile team will not care what happens to it. Continuous integration, on the other hand, requires developers to integrate their work with one another as early as possible in the lifecycle. This helps exposing bugs and issues on a regular basis. Continuous delivery provides tools and best practices to deliver quickly. At the end of each CI build, software is delivered for QA testing and then for delivery to the production environment. And as you can see, continuous delivery stretches out up till the deploy phase. But what about continuous operation and monitoring? This is where DevOps comes into picture. DevOps is to give end-to-end business solution for faster delivery of products to the market. DevOps is all about taking software which is ready for release and deploying it in a reliable and secure manner. So now you know what CI and CD are, but as we said earlier, DevOps is an entire paradigm shift and it instills a continuous culture. That means that DevOps is all about continuity at every stage of the lifecycle. It's a process for iterative software development and is an umbrella over several other continuous processes, including continuous development, continuous testing, continuous release and deployment, continuous monitoring, and continuous feedback and optimization. Adapting DevOps to support the entire software development lifecycle with an emphasis on agility and efficiency regardless of function provides several benefits. Some of these benefits include a curated culture, where your teams are more connected and the workers are more efficient, where you have greater employee engagement and collaboration with increased personal and professional growth opportunities. The other benefit includes tighter technicality, which provides improved overall software quality with more simplicity and less complexity. It provides quick problem resolution and greater stability and reliability with continuous delivery. The DevOps benefit also leads to better business yields with lower IT cost, quick delivery times, more predictability, increased flexibility, and heightened innovation. To wrap up, in this lesson, we understood the drawbacks of traditional approach in software development and realized how DevOps effectively serves the purpose of reducing the time involved in software development lifecycle for prompt deliveries and securing continuous production of high quality, foolproof software applications. I hope you found this lesson useful. Thanks for watching. Hello, and welcome to this lesson on OCI DevOps service. Before we define the specifics of OCI DevOps as a service, let's generally define the DevOps in the cloud. DevOps automation is becoming cloud-centric. Most public and private cloud computing providers support DevOps systematically on their platform, including continuous integration and continuous development tools. This tight integration lowers the cost associated with on-premises DevOps automation technology and provides centralized governance and control for a sound DevOps process. DevOps in cloud is a suite of managed cloud-based tools that forms a pipeline for code and bug tracking, automated unit testing and deployment, and reviewing and monitoring. Now, the question is, why use DevOps in cloud? There are several reasons why customers would want to use DevOps in the cloud. Some of those reasons include it saves time and energy. Building DevOps infrastructure requires a lot of work. A pre-built solution will save time and energy. Next is it collapses into single silo for collaboration. DevOps minimizes the silos and gaps by eliminating the boundaries between the conventional developer and the operation rules. This ensures business continuity, accountability, and desired results across groups. DevOps also helps you automate the entire deployment process. It helps you lower cost for development, testing, deployment, and operations. It's much easier to track cost of development resources and make adjustments as needed. Let's understand OCI DevOps as a service in more detail. The Oracle Cloud Infrastructure DevOps service is an end-to-end continuous integration and continuous delivery platform for developers. This service makes it easy to build, test, and deploy software and applications on the Oracle Cloud. With the help of OCI DevOps service, you can create private code repositories to store and manage source codes. You can also mirror external repositories from GitHub, GitLab, and Bitbucket Cloud to OCI code repositories. It helps you build and test your latest changes in a build pipeline with a service-managed build runner. You can set up a trigger to automatically run your build pipeline from a source code commit or pull request. Optionally, you can run a deployment pipeline on the successful build run for a complete CI/CD automation. It lets you orchestrate your software deployment across regions to OCI platforms such as Container Engine for Kubernetes, also known as OKE, and compute instances and functions. It helps you avoid downtime during deployments through the blue-green and canary deployment strategies. It helps you automate the complexity of updating applications. Automation reduces the chance of human error that might introduce a security vulnerability. It enhances the security and reduces risk in delivery. As DevOps enables faster software delivery, security bugs can be resolved quickly by rolling out a fix. Let's take a look at some of the DevOps as a service benefits. The first benefit is automation. The OCI DevOps service fully automates the software delivery lifecycle and thereby increases the speed of development and reliability of application delivery. It eliminates manual error-prone methods of application integration and deployment and increases the reliability of operations. Next is scalability. OCI DevOps service scales your builds with service-managed build runners. You can run concurrent builds and don't need to manage or operate the underlying build runner host. Integration and interoperability. DevOps service works with your existing Git repositories and continuous integration systems for customers building new cloud-native applications or migrating existing applications to OCI. The DevOps service is integrated with OCI services such as virtual machines, Oracle Container Engine for Kubernetes, Oracle Functions, artifact repositories, vault secrets, policies, and much more. Low risk of deployment and faster time to market. With OCI DevOps deployment pipelines, you can reduce change-driven errors introduced by manual deployments. Instead, perform rolling, canary, or blue-green deployments and optional automated rollbacks. All these capabilities lead to reduced risk, complexity, and eliminate downtime of your production applications. Last but not the least is the low cost. For deployments, customers pay only for the resources used by the targets of their software deployments. To wrap up, in this lesson, we introduced you to OCI DevOps service and discussed the benefits it offers to developers to simplify the software delivery lifecycle. To all the DevOps enthusiasts who wish to get started with the DevOps service, I would recommend that they go through the OCI DevOps professional learning path. I hope you enjoyed this lesson. See you in the next one. Thanks for watching. Hello, and welcome to this lesson on OCI DevOps CI/CD. I am Mahendra Mehra, and I'm a senior training lead and evangelist with Oracle University. So let's get started. Continuous integration and continuous delivery or deployment is DevOps best practice. With continuous integration shown in the blue on the screen, incremental, frequent code changes are built, tested, and revised as needed based on constant feedback. The term refers to the fact that the small changes and error fixes are continuously integrated into the code repository. Small frequent changes are easier to manage because errors are small, seen early, and less likely to conflict with other code merges. CI/CD tools trigger automatic, standardized build and test steps that ensure the code changes being merged into the code repository are error-free and work with the existing code. This shifts the focus from problem detection to problem prevention, which is also called shifting left, as it moves code failures to earlier in the process. Early fails are quicker and cheaper to fix. Once the main code branch passes unit, integration, acceptance, and other tests, it is then released to production in either an manual continuous delivery process or an automated continuous deployment mode, which is shown in the green on the image. Continuous feedback, shown in the gray region, is also a key part of the DevOps process. Here's the overall OCI DevOps structure and workflow. Let's take a closer look at the OCI DevOps service offering. OCI DevOps project is a logical grouping of DevOps resources needed to implement a CI/CD workflow. DevOps resources can be artifacts, build pipelines, deployment pipelines, external connections, triggers, and environments. The Developer Associate certification focuses on the services like Container Registry, OKE, and functions. But having knowledge of the OCI DevOps service like build and deployment pipeline can help you automate the process for continually integrating software development changes. You can learn more about the OCI DevOps service from the official documentation or by exploring the learning path on how to become an OCI DevOps professional. Let's take a look and understand the OCI DevOps workflow right from committing the code changes till its deployment on the live servers. The heart of the workflow is the build and deployment pipelines with continuous integration and continuous deployment. The build pipeline follows a user-defined flow to build the code, test the package, and deliver them as code artifacts in the OCI artifact registry or as ready-to-ship image in the container registry. The deployment pipeline then uses the build image from the container registry and a Kubernetes manifest to deploy the most recent version of the application to a staging environment. After the final tests and approvals, the pipeline pushes the image to the desired production environment, which can be a group of compute hosts, a container engine, or a function, completely based on the architectural design of the software application. You might also want to move an existing application from on-premises or another cloud to OCI and move software delivery and deployments to the OCI platform. The OCI DevOps service also has the flexibility to integrate with your existing CI/CD workflows. To wrap up, in this lesson we covered the OCI DevOps CI/CD pipeline and using an illustration saw how a CI/CD pipeline automates your software delivery process. I hope this lesson was useful. Thanks for watching.
Welcome to the Function Service Overview module. What is Oracle Functions? Oracle Functions is a serverless functions as a service offering. It is fully integrated with the Oracle Cloud infrastructure. Functions is a container native platform, which means your functions are deployed as Docker images and run as Docker containers. Functions is based on the open source FN project. Functions is secure using Oracle Cloud's security constructs such as networking, identity and access management, compartments, and many more. Let's look at some of the benefits of Oracle Functions. Functions is a pay-per-use platform, which means you only pay for the function execution and you're not paying anything if your functions are idle. The platform is autonomous, so it takes care of provisioning, managing, and auto-scaling your functions for you. And as a user, you do not have to worry about any of these concerns. It's an event-driven platform. There are a number of Oracle Cloud Infrastructure services which can automatically trigger your function code for you. So how does it work? They give you a function CLI, you write your function code, and you run a command that will package the function code as a Docker image and push this function image to a registry. The next step, you will configure a function trigger. Now, what is a function trigger? A function trigger is the condition when you want to execute this function. An example of a function trigger is an HTTP request made to invoke the function. Your code will run only when it is triggered. So in this example, your code will run when somebody makes a request to invoke your function. And you pay only for the code execution time. So there is no charge for idle time. Let's look at the function pricing. There are two dimensions. One is the number of function invocation requests, and the second one is the resource usage, which is the amount of memory that you consume when your function was running. Functions pricing has an inbuilt generous free tier. So the first 2 million requests and 400,000 gigabyte seconds are free per month. And above that, when you exceed the free tier, there is a small charge that you pay for using additional requests and additional gigabyte seconds. Our free requests are twice the number of AWS Lambda free requests, and our GB second pricing is 15% less than AWS Lambda's pricing. Functions is polyglot and container native. Functions are packaged as Docker images and run as containers. This lets you package and reuse open source libraries as functions. We have rich support and function development kits or FDKs for Python, Java, Go, Node, and Ruby. And for advanced use cases, we allow you to bring your own and customize the FN generated Docker file. We allow you to use Micronaut microservices framework and GraalVM native, which will help you reduce your Docker image size and memory footprint. Let's move to functions integrations. There are a number of services in OCI that can trigger functions automatically for you, like the event service, the API gateway, and so on. You can also use the CLI and the SDK to trigger your functions. When your function is triggered, we pull the Docker image from the OCI registry and start the function container. In your function code, you can use any of the downstream services like object storage, autonomous, compute, the secret service, networking, and many other services. Any logs, metrics, and traces that are generated are sent to OCI logging, monitoring, and APM services respectively. Hi, welcome to the next module. This is function triggers. In this module, we'll take a look at all the services that can trigger functions automatically in Oracle Cloud Infrastructure. We'll start with the event service, then look at notification service, then we look at the service connectors, followed by API gateway. In addition to these, we also have Oracle Integration Cloud that can trigger functions, and of course, you can use the CLI and SDK as well. Let's begin with the event service. The event service provides real-time fast alerts on state changes of OCI resources. You may have a number of other OCI resources like compute instances, storage buckets, networks, databases, and so on. These services are constantly emitting lifecycle change events. Oracle Event Service is a nice way to keep an eye on these events and take some action based on certain lifecycle events that you're interested in. For example, if somebody starts a compute instance, you may want to get notified. Somebody creates a public bucket, you may want to make that bucket private, for example, and so on. So Event Service lets you define rules where you can keep an eye on the events that you're interested in and perform certain actions, which would be you may want to write the event to a stream, you may want to send a notification email or a Slack alert to someone, or you may want to take some corrective action using an Oracle function. Event Service follows the Cloud Events standard. The next service we look at is the Notification Service. Notification Service is a fully managed multi-tenant pub/sub service. Again, it is fully integrated with OCI, so it integrates with events, monitoring, Service Connector Hub, functions, and a number of other services. It supports a wide variety of endpoints, such as email, PagerDuty, Slack, functions, HTTPS, and so on. And finally, notification service is enterprise grade, so it's fully secure, highly reliable, has low latency, and is durable. Up next is Service Connector Hub or Service Connectors. Service Connector Hub provides full visibility into data movement. It gives you a centralized experience to view, secure, and manage all data that's moving in the cloud. It allows you to take near real-time actions. Examples include easily emit log-based metrics. You can do one-click log archival, where logging becomes a source, object storage becomes a destination for your connector, and you can move logs, you can filter logs, and archive them in the object storage bucket. You can also perform automated remediation, alerting with functions and notification services. Service connectors also let you integrate easily with third-party tools. You can seamlessly move data to any destination using the Kafka-compatible OCI streaming service. You can also move logs from OCI to a third-party service like Datadog or Splunk or any other service of your choice. Let's look at the API Gateway service. The API Gateway service is a policy enforcement point. Guys. It allows you to define policies to authorize, throttle, and route attached requests that can help you protect your backend service APIs, which can then be implemented using services like Oracle Functions. API Gateway has integration with the authorization servers, so you can use Identity Cloud Service in Oracle or any other third-party provider that is capable of generating JSON Web Tokens or JWT tokens. Hi, in this module, we'll cover the functions service concepts. So what is a functions application? Functions application is a collection of functions. It is attached to the customer's virtual cloud network, which is VCN and subnets, and this is used for network egress. Application is also a unit of workload isolation. You can enable, disable logs, function traces, and set common environment variables or function configuration. What is a function? A function is a container image that is stored in a container registry, and metadata. Metadata contains the image location, the function memory, function timeout, and any configuration parameters or environment variables required for the function's execution. FNCLI is a command line tool that is used to manage functions. It has various commands that help you build, package function code as a container image, and then push the image to a container registry. It also has commands to generate boilerplate function code for languages such as Java, Python, Node, Go, and Ruby. What is the fn init command? The fn init command generates boilerplate hello world function. You can provide the runtime as a parameter, so you can select runtime as Java or Node or Python or Go or Ruby or Docker. In this example, we have given Java as the runtime language, and you can see the generated boilerplate Java hello world function. Let's look at the fn deploy command. The fn deploy builds the container image using a multi-stage Docker build. It pushes the container image to a registry, in this case the OCI container registry or OCIR, and then it creates or updates the function metadata where it keeps a pointer to the function image in OCIR. Let's look at the function configurations. As a user, you have control on the function memory. You can select one of 128 MBs, 256 MB, 512 MB, or 1 GB or your function memory. The next parameter that you can configure is the function timeout, and today Oracle Functions supports a maximum of 5 minutes for function timeout. The other configuration parameters that you can specify are environment variables, which you can define at the function or the application level, and then within your function code, you can access these parameters at runtime. The function service will ensure that the values are sent into your functions and they are available for you to consume. Examples of environment variables are database username, password, secrets which are used to access REST APIs, and so on and so forth. The other configuration is the function service limit. Today, there are 3 service limits. One is the number of functions, the number of applications, and the overall function concurrent execution memory. All 3 limits are soft limits, and you can easily raise a service request from within the OCI console to get these limits increased. Moving on to functions observability. There are 3 key pillars: metrics, logs, and traces, and the function service supports all 3. First, the function metrics. The function service collects metrics and sends it to the OCI monitoring service. You can easily view metrics in the OCI console. Function service integrates with OCI logging and sends your function logs to the OCI logging service by default. To generate logs, you need to have print statements or log statements inside your function code. You can also send logs to a third-party service using syslog endpoints within the function service. Function service can also generate and send traces to the application performance monitoring service in OCI. And we have a troubleshooting guide in our service docs that has the list of error codes within the description and the resolution steps to help you troubleshoot functions. Using other services from functions. A function can use other services in OCI like object storage, secrets, compute, network, and several others, or it can access services on the public internet. Function supports fine-grained access control. You can use functions resource principles to control what your functions can access. For example, if a function needs access to read an object storage bucket, you can put the function in a dynamic group and create a policy to allow that dynamic group to read files from that object storage bucket. Functions can access any service in OCI using a private subnet and the service gateway. Similarly, to access a public service, you can have an internet gateway in your VCN and subnet configuration.
Hello, and welcome to this demo on Functions Quick Start on Cloud Shell. I am Mahendra Mehra, and I am a senior training lead and evangelist at Oracle University. We will be breaking this demo into 4 steps. As part of the first step, you'll have to set up your tenancy. While setting up your tenancy, you must ensure that you have suitable users and groups. You must also ensure that you have right compartments, VCNs, and subnets. And finally, you must create policy for group and service. So let's switch to OCI console and see all of these in action. Alright, so I've logged in into the OCI console as tenancy administrator. Let me take you to the users and group and show you the users and group which I've already created for this demonstration. I'll click on the hamburger menu, go to the identity and security service, click on domains, and select the default domain. If you see, there is a users tab over here and there's a groups tab in my default identity domain. If I select the users tab, now as you can see, there are 2 users, Mahi Mehra, and the other one is the tenancy administrator. So we'll be using Mahi Mehra user in order to work with OCI function. Let me take you to the groups section. As you can see, I've already created a group called function underscore admin. And the use of this group is to bundle all the users together who work with the OCI function service. So if I click on this group, you'll see that Mahi Mehra is a user who's already added to this group. All right. Now let me show you the compartment that I've created to work with OCI function. Let me click on the hamburger menu, go to identity and security, and click on compartments. As you can see, there's a compartment called functions underscore demo that is already created. And we'll be creating our function within this compartment. Now, for the user and the group that we have created to work with OCI function and the compartment where all the function resources will be created, we must write OCI policies for both the groups as well as the service. Let me take you to the policies. Click on the hamburger menu, go to identity and security, and click on policies. Let me select the root compartment. If you can see, I have already written policies under a policy name functions underscore policy. If I open it, these are the list of policy templates that you can use in order to work with OCI functions. The use of policies totally depends upon the use case that you are following to create those functions. You can refer these policy templates from the OCI official documentation. As part of step 2 for this demo, we will be creating our first application. In order to create application, we will be logging in into the OCI console, and we will be logging in as the normal user, that is Mahi Mehra, in order to work with OCI function. So let's hop on to the OCI console. So as you can see, I'm at the cloud sign-in page where the cloud account selected is OCI developer training, the identity domain is default, and the user is Mahi Mehra. So let me quickly click on sign in. Now to create our first application, in the navigation menu, I will select the developer services. I'll select the applications under the function service. Make sure that you select the right compartment from the compartment section. In our case, it's function underscore demo. So I'll select function underscore demo and click on create applications button to start creating your first application. Give your application a suitable name. So I have given my application the name hello world-app. So now you need to select the VCN and the subnet in which you wish to run your functions. In our case, I've already created a VCN called function underscore demo underscore VCN. So it's auto selected within my compartment function underscore demo. And from the subnet section, I can select if I wish to load the function in a private subnet or within a public subnet. Make a note that a public subnet requires an internet gateway in the VCN and a private subnet requires a service gateway in the VCN. Let me go ahead and select the public subnet. I leave the tagging options as blank and click on create. So as you can see, our application hello world-app has been created. So as this demo is about working with functions using Cloud Shell, in the third step, we will be setting up our Cloud Shell dev environment, where we will be setting up the FN project CLI context. We will be generating an authentication token, and then using the authentication token, we will be logging into the OCIR registry, which is our Oracle Cloud Infrastructure Registry, also popularly known as OCI Container Registry. So let's jump back to the OCI console and see these steps in action. All right, so in the step 2, we created an application called hello world-app. Now, as you can see in the resources section, we have this getting started page where we can use the Cloud Shell setup in order to access our OCI function, or we can use a local setup if a developer is comfortable working with a development machine that he owns. For this demo, we will be going ahead with Cloud Shell. So you can simply follow the steps given in the getting started page in order to launch your first Hello World application. So as I said, we need to launch the Cloud Shell in order to configure the FN project CLI. So let's click on the launch Cloud Shell. Either you can use this button to launch the Cloud Shell, or you can invoke the Cloud Shell from the menu bar. Let me click on the launch Cloud Shell button. And as you can see, it's creating the Cloud Shell machine for us. All right, so my Cloud Shell is up and running. Let me maximize the Cloud Shell. So the first command that we'll be running to set up the FN project CLI context is the FN list context command. What this command does is it helps us to find the name of pre-created FN project context for the current region in which we wish to create the application. So upon hitting enter, so if you see the output of the command, I see that there are two contexts. One is the default and another is the region name where I basically want this function to be created. So I basically need to switch the context from the default to AP-Mumbai-1 region. For that, I'll be using the FN use context command followed by the region name. All right, so there is the command FN use context space the region name, which is my current region. Let me hit enter. And now the context has changed to AP-Mumbai-1. To cross check, you can use the FN list context command and see that the selection has changed from default to AP-Mumbai-1, which is the region where I wish to create this function. Now the next thing is to configure the FN project context with the OCID of the current compartment that will own the deployed function. In our case, the compartment is function underscore demo. So this is the command which is used to set up the context to the OCID of the compartment. FN update context oracle.compartment-id space the OCID of the compartment where you wish to create the function resources. So this compartment ID over here is the compartment ID of function underscore demo that we had created earlier. Let me go ahead and hit enter. And as you can see, the current context is updated for the compartment ID. Now, the next step is to configure the FN project context with the Oracle Cloud Infrastructure Registry address in the current region and tenancy that we want to use with the Oracle function. So as you can see, the command is FN update context registry followed by the registry address. So as you can see, the registry address is the regionkey.ocir.io, where the region key for AP Mumbai is BOM, and it is slash separated by the tenancy namespace and slash separated by a repo name prefix. You can give any customized name as per your use case. So let me go ahead and click enter. As you can see, the current registry context has been updated. Now, as part of the next step, we need to generate an authentication token. So let me go ahead and click on the profile menu and go to my profile. Let me minimize the Cloud Shell. Now, on the My Profile page, you can see under the resources section, there's an auth tokens option. Let me click on auth tokens and generate an auth token for this particular use case. So let me click on generate token, give it a valid name or description, and click on generate token. So the token has been generated. You must ensure that you copy this token and save it somewhere. So let me copy the token and save it. Let's close this window and go back to our functions. So let me go to the hamburger menu, click on developer services, go back to applications, click on my application. Let's maximize the Cloud Shell. And the next step is to log in into the OCI registry using the authentication token. So the command is docker login -u followed by the username, which is the tenancy namespace slash separated by your username and the registry address. So let me hit enter. And in the form of password, you need to provide the authentication token that you just generated. So I'll paste the authentication token here and hit enter. As you can see, I've currently logged in into my OCIR registry. Now we can verify our setup using the FN list apps command to check which applications are created under our current context. So I'll go ahead and write FN list apps and hit enter. As you can see, there's only one application which is currently created under the compartment function underscore demo called hello world-app. Now with this, we complete our step 3. Moving on to the step number 4. As part of step 4, we will be creating our first function. We will deploy it to the OCI functions, and then we will invoke our function. So let's again switch back to the OCI console. Alright, so in order to create our first hello world Java function, we'll have to use the fn init command.